Hello everyone, so in this video we're going to find which of the following compounds has the lowest dipole moment. So I'm going to go ahead and paste some symbols and definitions here that are pretty essential to knowing for this problem. So the ability of an atom to attract the shared pair of electrons towards itself is what we call electronegativity. The dipole moments occur in bonds as a result of differences in the electronegativities of the bonded atoms. The difference in electronegativity results in the separation of charge, creating what we call a dipole moment. So the more electronegative atom has a partial negative charge, while the less electronegative atom develops a partially positive charge. We have our dipole arrow here, and we also have these symbols going on here. So for our partial positive atom, we get this delta plus symbol. So delta just means a partial, and then of course plus for positive. Same thing for the partially negative, we have this lowercase delta Greek symbol, and then minus for the negative. This is our dipole arrow here. For our tail and the tip. So for my tail here, if I zoom in, I see sort of a plus sign. And of course, by default, the other end, which is going to be the tip, is going to be a negative sign. So because I see sort of a positive here, this means that this is where the partially positive atom goes, and then the arrow will be pointed towards the partial negative one. So that's how I kind of interpret this arrow. It makes it easier for me when I'm going to go ahead and draw out these structures and draw in these arrows if necessary. So first thing we could do to do this problem is sort of draw a simplified version of a Lewis structure for each of these compounds. So starting off with compound A, we have lithium and chlorine. So simply just draw the bond itself. So another thing to keep in mind if we don't have the electronegativity values is just knowing if something is symmetric or not. Symmetry can be used to determine if a molecule is going to be polar or not, and that also leads to electronegativities and dipole moments. So for lithium chlorine, of course, since we just have two atoms, we see that we do not have a symmetric compound, so that's going to have or conclude in a non-zero dipole. All right, now moving on to option B, which is BCl3. So we have a boron in the central atom here, connected to 3 chlorine atoms. So again, I'm not going to go ahead to draw in the lone pairs because we are just doing a simple Lewis structure. So we know that chlorine is going to be more electronegative than boron, so we can go ahead and draw in those arrows in the structure. To make it easier on the eyes, we can also do it outside of the structure. So again, we have a dipole going to the left, going off to the right, and one going straight down. Because these three are in opposite direction of our dipole moment, then this will lead to a net dipole of 0. So we have a 0 dipole going on for option B. Now moving on to option C here, that's NaCl. We already know that this is a ionic bond, so technically there's no real bond between the sodium and chlorine, but again, we're just doing a simplified Lewis structure. We already see that this is not symmetric, so again, we have a non-zero dipole. And lastly, just scrolling down here from our space, for option D, we have KCl. So similar to NaCl, we again see that there's no symmetry here. Since there's only two atoms, the potassium and the chlorine, this will lead to a non-zero dipole moment as well. So again, taking a look at the drawn structures here between options A through D, we see that the only option that gives us a 0 dipole is going to be option B. Again, that's because all the dipoles here are symmetric and they cancel each other out. So we get a 0 net dipole moment. So our answer then, to answer which of the compounds has our lowest dipole moment, that's going to be option B. So I'm going to go ahead and highlight option B as my final answer for this problem.